Okay, so this is for the second part of 8.1 for pre-cal. These are those word problems that you're going to see. One of them says something like points A and B are opposite sides of a lunar crater. So you've got A and B here. And they're opposite sides, so you can draw that. And then the measure of angle BAC. So I'm going to go and finish this triangle. The measure of angle BAC is 20 degree. Hold on. Nope, that's not it. Sorry. Yeah, it's 115. The measure of angle BAC is 115. And then the measure of angle ACB is 45. So this right here is 45. And they want to know what the width of the crater is. So this is the crater right here. So we want X. So we need to find X. So we need to set up law of sines, but we need one other measurement. They tell us that point C is 46 meters from point A. So point C is 46 meters from point A. So now we've got what we need to set up law of sines. We can find angle B by just doing 180 minus 115 minus 45, which will give us 20 for angle B. Then we can set up law of sines and put side 46 over sine 20, because that's law of sines, side over sine of angle, and then x over sine 45. So x over sine 45. I'm getting a bad glare from my skylight. Okay, and then again, just like on the other video, there's only one move that has to be made. That sine 45 has to move up to the 46. So 46 sine 45 over sine 20 equals x. And then type that in your calculator and round it to whatever he has to round it to. Sometimes hundredths, sometimes whole number. So 46 sine 45 divided by sine 20 gives about 30. Okay, make sure that your calculator is in degrees, because I did not. So make sure your calculator is in degrees. Make sure you close parentheses after the 45. And make sure you put it in correctly. Oh my goodness, 45 sine 45 divided by sine 20. Wow, okay, there we go. So it's 95.10 if we wanted to round it to the nearest hundredth, and it's in meters, okay? So that's one of the things you're gonna see about the crater and finding the distance of the crater. Okay, then another one, you've got a new homeowner has a triangular shaped backyard. So a triangular shaped backyard. Two of the three sides measure 50 and 40. Doesn't matter where we put them, 50 and 40, just as long as we got two of the sides on there. And then an included angle of 142. So an included angle means it's between the sides. So 142 is the included angle between those two sides. And then you just want the area of the yard. So that's where you do 1/2 AB sine of C. It's basically you just do 1/2 with the two sides because they are including the angle and the sine of 142. So when you've got those two sides and the included angle, you use this formula that comes from the law of sines. So 1/2 times 40 times 50 sine 142. And whatever you're asked to round it to here, I think you're asked to round to the nearest foot. So it's like 616 feet squared. So that's finding the area. Then sometimes you're given a triangle. So let's see, on this one, we've got a triangle like this. This is 73 degrees. This is 74 feet. They put a G here, and this is the barn. That's just the picture that you're given. You're given that picture right there. That's all put on it. And then this is I. This is G, and this is H. So that's the picture. You're given that picture. This is an I, not a C. So that's the picture. And then it says a zoo is building a new giraffe exhibit and needs to fence in the outdoor triangular area with the barn forming the side of the triangle. So a barn is forming the side. The maintenance department has, so the perimeter has to be 142. It has to be less than 142 because that's all the fencing that you've got. If one of the sides is 74, and then the other angle is 73, then we want to know if they have enough fencing. So we want to check it and see if they have enough fencing. So let's see. How do we want to find this? Okay, so we know one side has got to be 74, so we take that 74 out. So 142 minus 74 only leaves 68 feet. So that leaves 68 feet for I and G. So if we say we put, remember the barn is making this side, so it's just 68 feet for this side. Okay, so we just need to see if it works. We need to see if that's going to be enough. Okay, so again, the barn is making one side, so we don't have to put anything on I. We just had the total of 142, and a side length was 74, so we take that 74 out. The rest that they'd have is 68, so G has to be 68. So what we want to do is we want to find one of these. We want to find one of these other angles, which would have to be H, because we know side H. And see if it works, because we're just trying to make sure they have enough fencing to do this. So if we find H and it's a good angle, then we're good. Then it makes a triangle and we're okay. So we're going to find the sine of H. We're going to set up law of sines. Sine of H. Let me erase my old area and put this closer to the picture. So we'll put sine of H over 74, because again, it's the sine of the angle over the side length. And then sine of 73 over 68. So that's what that looks like using the law of sines. Again, sine of angle over side and sine of angle over side. So that's the way we set this up. Then we've got one move to make for the sine of H. It's going to be 74 sine 73 over 68. And then again, we've got to do inverse sine on that. I showed you how to find the angle measure on the other video. So we're just doing the same thing here to see if it does make a triangle. So then 74, actually not yet, second sine, 74 sine 73. And then we divide that by 68. And then, okay, I got a domain error. So like I told you, you've got to do that twice, because I got to make sure I plugged it in right. So I've got the second sine, I've got 74 sine 73. Okay, so I'm going to do it again. See if I get that again. Let's see, so second sine 74, sine 73, close parentheses, divided by 68. I still get an error again. So what that means is this. You only have 68 feet left, and it does not make a triangle. Does not make a triangle. Okay, so on the computer, it asks you a couple of things. The question is, does the zoo need more fencing? Okay, so yes, it needs more fencing. And then the zoo has 68 feet remaining. So this is one of the slots you're going to have to fill in. It has 68 feet of fence remaining. So you're going to have to fill in that. Then you're actually asked for the sine of H as a decimal, okay? So that means you're going to put just this stuff in. So to find this sine of h, you're going to put in 74 sine 73 over 68. Okay, not the angle measure. You just want to put that in. So to find that sine of angle h, you're just going to put this part in. Because we know what happens when we try to find the angle measure. It doesn't work. So we're going to put 74 sine 73, close parentheses, divided by 68. So it'll look like this on the calculator. And then you want to put that right there in to what they ask you to round it to. So you'll have to read that on the computer and see. Here I'm going to go ahead and put 3 decimal places. So that's something that you're going to have to fill in as well. So the deal is it did not make a triangle. When we did it, we got an error on this. We got a domain error, so it didn't work out. So it's not a triangle. And then when you look at your answers, since the question was, do they need to buy more fencing? The answer is yes, they need more fencing. They only have 68 feet of fencing remaining, you know, after we took the 74 out. We took the 74 out, that's how we found the 68. Then another question you're asked on this is the sine of h. You're asked to find the sine of h. So to find the sine of h, like we did up here, you just do 74 sine 73 divided by 68 and put that number in the slot that's there. Okay, so that's the one about the fencing with the barn, and again, you know, that barn side doesn't count, but they give you this drawing. So that's the way you do it. Subtract one side from the perimeter, set up law of sines to find the angle measure. Angle measure doesn't work. That means they need more fencing, and then fill in those 2 slots there. Okay. Then another one that you're going to see. Again, the triangle is drawn for you. So let me draw it right quick. Let me put everything on here that they've got. This is 9 degrees in here. This is 45 feet. This is 42 degrees. Let's see, I think this is A, C, and B. Okay, so that's what you're given. That's the picture you're given. It says a pole leans away from the sun at an angle of 9 degrees. So this is the pole. This right here is the pole. And it's leaning away from the sun at an angle of 9 degrees. When the angle of elevation of the sun is 42 degrees. So here's the angle of elevation. Remember, angle of elevation is always ground up. So there's the 42 degrees as the angle of elevation. And we want to know how long the pole is. So this is our x. This is what we want to find out. So if you notice right here, this is actually making a 90-degree angle. So I can find this angle really easily. It's the difference between 9 and 90 degrees. That's how I find the 81. It's 90 minus 9, because this is a right angle. And then that makes it easy to find this other angle. I just do 180 minus 42 minus 81, which gives me 57. Now I have all 3 angles, so I can set up law of sines very easily to find the height, length of the pole. So I would put x over sine 42, because x and sine 42, those are opposite each other. And then I'd put 45 over sine 57, because I've got 45 and 57. Those are opposite, and 42 and x are opposite. So x for the pole, sine 42, 45 over sine 57. Again, only one move needs to be made. That sine 42 needs to bump up with the 45. And then type that in your calculator. 45 sine 42, close parentheses, divided by sine 57. And then round it to whatever you asked to round it to. Sometimes it's nearest tenth, sometimes it's nearest hundredth, sometimes it's nearest whole. This came out to be about 35.90. So that rounds to 36 feet if you're asked to round it to the nearest whole number. Okay, then another one that has the drawing, because again, you can pause this, rewind it, whatever. So let's see, we've got, again, this is a drawing. This is the new airport. This is the original airport. Let's see, this is due north. They've got that on there. This is also due north that they've got drawn on there. Then they've got this reflex angle is 277 degrees. That's that reflex angle right there. They show this angle as 82 degrees. And then they've got this drawn on a deal like this, showing that that's your north-south and then east-west going here. And that's 80, whoops. That 82 degrees is inside the triangle, okay? Okay, then let's see. A reconnaissance airplane leaves its airport on the east coast of Country A and flies in direction of 82 degrees. Because of bad weather, it returns to another airport, 260 kilometers. So this right here is 260 kilometers. That right there is 260 kilometers. They've got that on the picture for you. Of its home. To get to the new airport, it flies in a direction of 277 degrees. That's this 277, which again is on there. And then what is the total distance the airplane flew? So we have to find this side and we have to find this side and count all of that, okay? Count the y and the x, so we'll add them up once we find them. Now, I need to find this angle measure right here, okay? Well, because these are both north. They're both due north. Oh, so we can find this angle right here. This, because I need this angle in the triangle. I need the angles in the triangle. I've got this one. I need this little one. And I need this one up here. Okay. Well, if this reflex angle is 277, I can find this angle in here by doing 360 minus 277. So then 360 minus 277 gives me 83. So this angle's 83, okay? Now, something from back in geometry, when you've got two parallel lines, because this line right here that they give you is going due north, and this one is also going due north. So you've got two parallel lines cut by a transversal. X is the transversal. So this 83 and this angle is also 83 because they're alternate interior angles between those two parallel lines. So this is 83 and that's 83. Now if I know 82 and 83, I can just do 180 minus 82 minus 83 because I've got to find this little angle right there. So 180 minus 82 minus 83 gives me 15. So that angle's right there is 15. Okay, so we had to do all that to find those angle measures so I can set up law of sines for x and y. Because setting up law of sines is not that big of a deal. Sorry, my finger just got in the way. Setting up law of sines is not that big of a deal once you have the angle measures you need and that kind of stuff. So we just had a little bit of work to get there. Again, you can rewind it and watch it again if you need to. But that's the way it's set up. Now we're ready to find x and y. So to find x, it would be x over sine 82 because the 82 is opposite the x. And then you would put 260 over sine 15 because 260 and 15 are opposite the triangle. So then x is 260 sine 82 over sine 15. Sorry. So there's my law of sines, and that's how I solve it. So 260 sine 82 close parentheses divided by sine 15 and you get about 994.79. And we are rounding to the nearest integer. So I'm going to round that. This is x, so it's 995. I'm going to round that one. We've got to find y, and then we've got to add them up. Okay? So now to find y, it would be y over sine 83, because y and 83 are opposite. And then I'm going to use the 260 and the sine 15 again. So then for y, there's one move that needs to be made. That sine 83 needs to bump up there. So then 260 sine 83, close parentheses, divided by sine 15. And that's 997, about 997. So y is 997. And then we add those two up, because it had to, the plane had to get back, so it had to travel here, that kind of thing, okay? Well, actually, it traveled here because it went off, and then had to travel back. So we just add the 997 and the 995. And get 1992 kilometers. So that's the total distance that the plane had to fly. Okay, then one last one where you're given the drawing again. And this will be all of 8.1. Okay, so then we've got a triangle. Again, this is given. This triangle is given. All the drawing on it, all the numbers and stuff are given on it. This is 50 miles. This has another, due north thing going on and another reflex angle. So this reflex angle comes around to that part. And then that's a 311 reflex angle. 311. Okay, that's B. This is A down here. And this is C. Then from A, you've got another due north coming up here. Another due north. And then let's see, from that due north to this is 54 degrees. Then we've got another reflex angle to here, which is 312. Okay, let me make sure that's everything they've got drawn on here. Got the 50. Okay, you've got the 50. Got the 311. Got the 312. Got the due north. Okay, got that angle C. Okay, so it says a ranger in Tower A spots a fire in the direction of 312 degrees. A ranger in Tower B, located 50 miles at a direction of 54 degrees. Again, that's all drawn for you. Spots the fire at a direction of 311. So that's that 311. And that other ranger is at 312. How far from Tower A is the fire, and how far from Tower B? So the fire is at C. Here's the fire. That's where it shows the fire is. And then we want it from Tower B, and we want it from Tower A. So we want those two distances right there. We want those two lengths right there. So again, finding angles here, needing to find angles. Well, again, I've got this reflex angle of 312. So to find this little piece here, which would complete this angle opposite y, okay, we need that whole angle, I would just do 380 minus 312. Not 380, oh my gosh. 360 minus 312, which is 48. So that would be 48. That would give us this whole angle that we'll have to use here in just a minute. Okay, then over here, again, I could find this piece right here by doing 360 minus 311, which would give me 49. So this piece is 49. That piece right there is 49. And, is that going to help me? Yes. Okay. So again, they give us this due north thing, and then they give us another due north thing. So again, you've got two parallel lines cut by a transversal, cut by this transversal. So this angle right here is 49. Now you're probably like, why does that help us? Because I can take this smaller triangle right here and use 49/54 and get that small angle. Get that angle. Okay. And then for the big triangle, I'd use this angle, this full angle, to find that angle that we need where the fire is, okay? Because we have the distance opposite the fire, so I've got to have the angle at the fire. And that's the way to do it. Again, due north, those are two parallel lines cut by a transversal, and alternate anterior angles are congruent. So to find this angle right here at angle B, I'm going to do 180 minus 54 minus 49, and that's a 54. 180 minus 54 minus 49. So that gives us 77. So this angle right here is 77. Then to find the angle where C is, or where the fire is, I need to add 48 and 54. This is 102. So this whole angle is 102. Okay, so then I take 180 minus 102 minus 77, and I get 1. The angle right there is 1. But that's okay. I mean, I can have an angle measure of 1. So now I need to find X and Y again, because I want two answers. I want from C to B. I want fire from tower B, which I'm calling fire from B is Y. And then fire from A is X. So make sure you put them in the right places. Make sure that you put them in the right slots, or the computer will count it wrong. So be careful with that. Okay, so I'm going to find X first, actually. So that would be, looking at my triangle, X goes over sine 77, because X and 77 are across from each other. And then 50 over sine 1, because those are across from each other. So then one move needs to be made. The sine 77 needs to move over sine of 1. So then 50 sine 77, close parentheses, divided by sine 1, gives me 2,791.5, which would be 2,792, rounded to the nearest whole, and it's in miles. Sorry, glare. Okay, then to find Y, again looking at the triangle, it'd be Y over sine 102. And I'm going to use 50 over sine 1 again. So then 50 sine 102 over sine 1. So 50 sine 102 divided by sine 1. Y sine 102. Y over sine 102. 50 over sine. I did my calculator wrong. 50 sine 102 divided by sine 1. There we go. Okay, so it's about 2,802 miles. Okay, so that's all the word problems you should encounter. Again, this isn't due until Friday at 11, I think. It's either 10:25 or 11. But it should show that on the computer. Just make sure you get it turned in, and I'll send this as quick as I can, and then I'll get the one up for 8.2 that you've got to do for Friday that's not due till Wednesday. I'll get that one done hopefully pretty quick as well.